Hello, my name is Brandon Cody, and this is my video for Lab Module 4, Part A. This is a video of the setup with the ADC converter. I'm using the ADS1115. This here is a code I'm using, which I got from the Canvas webpage. Up here we are including a library that works for both the ADS1115 ADC and the ADS1015. Down here we are setting the bit resolution in millivolts, 0.125. Here we have the thermocouple constants, which is used for converting voltage readings to temperature. In the void setup, we're setting the gain to 1 because we're going to try to measure the 3.3 volt power source on the Arduino first. And as we can see, using a 1 times gain will be necessary because the max voltage is 4.096 versus if we were to use a gain of 2, the max voltage would only be 2.048, which is not significant enough to measure the 3.3 volt source. In the void loop, we have a few lines of code that's going to print the information we want to see. We're going to see how much time has gone by in seconds, as well as the microvolts measured between the A0 and A1 pins on the ADC. And it's also going to display the temperature, but this will apply mostly to the experiment with the thermocouple. And now let me run it here, and we'll go to the serial monitor. Right now, microvolts measured is 0. It's because I have both the A1 and A0 pins on the same rail. However, if I put A0 on the 3.3 volt source and A1 on the ground, I go back over here, we can see that we are now measuring about 3,300,000 microvolts or 3.3 volts, which is what we expected to see from the Arduino source. Thank you. This is my video for using the ADC to measure the voltage of a 1.5 volt battery. The only difference in the code is that I've changed the bit resolution to 62.5 microvolts. This is because we're going to try measuring the voltage of this battery with a gain of 2, as according to this table. Down here we're going to read the raw ADC value, convert it to millivolts and then microvolts. And it's going to be hard for me to touch the terminals of the battery together while recording. So I'm going to aim the camera at the serial monitor and then go in and touch the probes to the battery. Right now the probes are on the same rail. We're reading 0 volts measured. I'm touching to the leads of the battery and we're seeing about 1,270,000 microvolts or 1.27 volts coming out of the 1.5 volt battery, which means that just a little bit of the battery life has been used out of this AA. Thank you.